So just want to remind you the types of aircraft movements with respect to the gyroscopic coupled generation. So these are the three movements you have to remember. So this is your pitching motion about the red axis, pitching. This is your rolling motion about the green axis. This is the yaw motion about the blue axis. So please remember these three types of motion. When you have the propeller is always rotating around the green axis. Now with that, if you give the blue movement, you will get the red movement, or if you give the red, you will get the blue. So that is the concept of gyroscopic effect on aircrafts. So the assumption is you always have the either your propeller or the gas turbines. Any one of the rotors are always going around in the green axis, right? So with one rotation present, you give the second, you will get the third. You give the active couple, you will get the reactive couple. So that is your gyroscopic concept. Now we will see the first problem. I mean, we are going to see only one problem on aircrafts because aircraft and ship are almost exactly similar. So this is your first problem on aircraft problem. Okay, so an aeroplane makes a complete half circle of 50-meter radius. So this 50-meter is the path in which your aircraft is traveling. Let us take an aircraft. Okay, let us say this is an aircraft and this is going to make a circle, half circle, and the radius of this half circle is 50 meter. The path radius. Okay, so it is 50-meter radius towards left when flying at 200 kilometers per hour. Okay, the rotary engine and the propeller of the plane has a mass of 400 kg and radius of gyration 0.3 meter. Okay, so this is together with the engine, we are going to consider this as a propeller mass only, and then we are going to calculate the moment of inertia of the propeller with respect to this moment of inertia. Okay, the engine rotates at 2400 rpm clockwise when viewed from the rear. That is very important. Where you are viewing from, I am sitting in the pilot seat and then I am looking at the propeller in the front. So I am seeing it going around in clockwise direction. Find the gyroscopic couple on the aircraft and state its effect. So there is a separate mark for this conclusion you are going to give, not just the numbers. You can easily find out the value of I omega omega p, and there is a separate mark for the statement you are going to give. What will happen to the aircraft, whether it will go down or it will go up, that you have to state separately. Okay, so let us list down the given data. So path radius is taken as capital R here. So capital R is 50 meter. Velocity of the aircraft is 200 kilometers per hour. Now convert that into meter per second. It comes from 55.6. I know I think you know how to do this. 55.6 meter per second. So mass of the propeller is 400 kg and its radius of gyration is 0.3 meter. And the propeller goes around at 2400 rpm. Convert that into 2 pi n by 60. You will get 251 radians per second. Keeping all these data in hand, I am going to move into the calculation. First, find out the moment of inertia of the propeller. So I equal to mk square. So mass is 400 kg and radius of gyration is 0.3 meter. Okay, so this mass is 400 kilogram. Radius of gyration is given as 0.3 meter or 300 millimeter. Now you do this calculation mk square, you will get the radius of the moment of inertia of the propeller is 36 kilogram meter square. Angular velocity of precession. So that is your 100 kilometers per hour. Now I converted that into meter per second, right? So now that is 55.6 meter per second divided by your radius. So convert this. See, linear velocity is 55.6 meter per second. Now I want to find out the angular velocity. Okay. So that angular velocity, why you are calling it as precessional velocity? Because the propeller velocity is that omega, 2400 rpm omega. That is your first velocity. Second velocity is I am going to call as precessional velocity. Now that is your actual aircraft velocity. What is the speed at which you are traveling if you are sitting in an aircraft? That velocity is the velocity of precision. Okay, that is 55.6 or 200 kilometers per hour converted to meter per second, 55.6 divided by the radius in which you are taking the curve. I already told you the radius of the path capital R is 50 meter. You are making a large circle of 50 meter radius. So that 50 you are going to put here V equal to omega into R, right? So omega equal to V by R. That formula is used here. I am going to find out the angular velocity in radians per second for this velocity of precision. Okay, so that comes around 1.11 radians per second. Okay, so that I can directly go for calculating gyroscopic couple I omega omega p. Okay, there is only one formula here, I omega omega p for aircraft or ship, whatever. Okay, a gyroscopic couple acting on the aircraft is I omega omega p. Omega is the rotor speed omega p is the precessional velocity 1.1 radians. At what angular velocity you are covering the circular path. So I is 36 kilogram meter square moment of inertia. The rotor speed is 251 radians per second, that is 2400 rpm, which you converted to radians per second, it is 251. So precessional velocity, the angular velocity at which you are traveling in this circle of 50-meter radius is 1.1 radians per second. Now put all these numbers into this I omega omega p formula. So gyroscopic coupled C equal to, so your moment of inertia is 36. So in place of I am putting 36 kilogram meter square. Omega is the rotor speed, angular velocity 251.4. Okay, and the omega p precessional path traveling velocity 1.11. So this answer comes, this is your gyroscopic coupled value. Active gyroscopic coupled value is 146, that is 146 Newton meter is the active gyroscopic coupled, the effort that the aircraft puts to take the turn. You have to exert a force of 146 Newton meter to take this turn. Okay, now this is going to come back to you as a reactive force. What will that reactive force do to your aircraft? That you have to state as a sentence or a statement. Okay, so let us write this in kilonewton meter. So that is 10.046 kilonewton meter is the active gyroscopic couple value. Now this is going to come back to us as a reactive couple, because you are having already the propeller is going around at some high speed 2400 rpm in let us say x, y, z. Okay, now my propeller is in this axis, my aircraft is traveling like this. Okay, now propeller is in this axis, I am taking a, this is your propeller axis of rotation is, let us call this as x axis. Propeller is rotating in this axis. Now I am going to take a circle. I am going to take a circle in this plane, horizontal plane. I am not going up or down. In the same plane, horizontal plane, I am going to take a circle of 50-meter radius. I am going to turn the aircraft. So the axis of this turn is actually the vertical axis, right? Yes, if we form a circle like this, the axis is vertical. A horizontal circle axis is actually vertical. Therefore, the third reactive couple will come to you in this axis, third axis. What will happen? Your flight will either lift up or it will go down about this axis. Your aircraft will wobble like this or like this. Okay, and it will move forward in that direction. Now that effect we are going to state. What is the value of active gyroscopic couple is 10.046 kilonewton meter. We know that active and reactive couples are numerically equal. The effect of this reactive gyroscopic couple is, as we have discussed earlier, that if you remember in the last class, we have put an entire tabulation and we have seen what will happen to the aircraft if something like that happens. In each case, we have seen that. You just go and check that video, it is available in the YouTube. We have discussed earlier that when the aeroplane turns towards the left with the propeller rotating in clockwise direction and view from the back, the effect of the gyroscopic couple is to lift the nose upwards and the tail downwards. Okay, there is an entire tabulation. There are 8 cases in which you can note down the effects. Okay, what is the easiest way to remember this? Clockwise rotation. We put a clockwise rotation split arrow marks. Okay, now go to the center. Now you turn to left, what will happen? Your aircraft will go up. So nose will go up, tail will go down. Okay, so that's the easiest way to remember that. Now if I turn to right, what will happen? My aircraft will go down. My nose will go down, but the tail will go up. Okay, front of the aircraft will go down. Obviously, the aircraft will start traveling in the downward path. So that is the easiest way to remember this entire tabulation. Similarly, for anti-clockwise rotation of the propeller, you remember like this. So now if you turn left, what will happen? Your aircraft will go down, nose will go down. Similarly, if nose go down, tail will immediately go up, right? Similarly, if you take a right turn in an anti-clockwise rotation case, your nose will go up and tail will go down. Just with this split circle arrow marks, you can identify these answers. It's the easiest way to do it. Okay, you don't have to by heart this entire table. So the effect is nose will point upwards and tail will point downwards. So the aircraft will start traveling upwards. It will pitch as a result of this reactive gyroscopic couple. Okay, so this problem is taken from your Kurmi textbook problem, example problem 14.3. So that